Hello and welcome to everybody who's here for another session in the A4Q Testing Summit Edition 2025, or who may be watching a recording. I am really happy to be here with Anne Kramer. Hello, Anne.
Hello, everybody.
Anne is from Smart Testing, and I've had the pleasure of interviewing Anne before for one of the ISTQB Women in Testing sessions. So I know that we're going to have some really great perspective and insights introducing technical debt. And I know that Anne is going to share her personal list of anti-patterns with you. So I'm going to hand over to Anne in a moment. Can I just say we'll have questions at the end. And also we always have our Best Presentation, Best Speaker awards. So if you can go to Anne's profile on the A4Q Testing Summit website and cast your votes at the end of the session, it would be much appreciated. Anne, I'm going to get off stage and hand over to you. Sit back, everyone, and enjoy.
Yeah, thank you very much, Debbie. I'm so glad I'm again part of the A4Q Testing Summit. And I want to talk about technical debt in testing. The idea for this presentation stemmed from a conversation I had with colleagues. We were discussing technical debt in coding and how they have their equivalent in testing. And during this discussion, I realized that while I agree on the problem and the origins of the problem, I somehow dislike some of the typical reactions that we have to solve the problem of technical debt, or to the causes of technical debt. And that's my personal list of anti-pattern, which I would like to present to see whether you agree and whether we may perhaps avoid the negative effects. So why do we have technical debt? But in my opinion, the cause is really pressure. One of the sentences I hate most in project management is that pressure makes diamonds. Managers tend to say that to explain why pressure is a good thing and that you will do your best when you are under pressure. But I do not agree. Absolutely not. Pressure causes heat. I've studied physics and I learned that, and this is true for cooking. When you cook, pressure causes disintegration of the meal, and the same happens in projects. When you add too much pressure to projects, you have heat, and this causes disintegration of what you're doing. And we have our ways to react at pressure. And those are patterns. And anti-patterns are the best. This is the best definition I found for an anti-pattern. Anti-pattern is a tried and true method for shooting yourself in the foot. So it's a pattern you apply, but it's not good for you. And we see this in coding. When we have technical debt in coding, when we have pressure in coding, we have typical reactions. And one is, for example, the cut and paste. Cut and paste, you just don't have the time to create a new function. So you just take the code and you paste it again, you change something, and it works. And you don't take the time to clean that up. Even if you know that this was a bad idea to do some cut and paste, or copy paste, is rather copy paste. You will never find the time to fix it. And that's where you start having technical debt. Another one is labor flow, or dead code. Dead code occurs when you no longer need that function. But honestly, you're not absolutely true whether it's not needed or because you don't have the time to verify whether it's still used, and you are afraid that maybe a colleague may still need it, so you leave it in, but it's dead code. Spaghetti code is a well-known coding anti-pattern, which means that you have a very, very complex code. The cyclomatic complexity of the code is very high. Functions calling functions, etc. The last one I took here is the big ball of mud. The big ball of mud means you never took the time to have an architecture, a proper architecture. So there's no structure at all in your code. And all those anti-patterns are caused by the fact that you have to go forward fast, and that you don't really take the time to do it well. But they cause problems. The major problem is maintenance, because when you have copy-paste problems, then you fix the code. You have a bug in your code. You fix it, but you fix it once and you think it's done. And the truth, in reality, you have the code twice, and therefore you should fix it twice also, but you don't see that because you no longer remember that you duplicated the code. That code can be already the fact that you have to understand that this code is no longer needed takes time. And of course, spaghetti code and the big ball of mud, it's obvious that maintenance is very difficult. So those are well-known anti-patterns in coding. What are the equivalents in testing? In testing, when you look at a test suite, you have possibly redundant tests. Or maybe it's not so obvious that the tests are redundant. Maybe it's just redundant test steps. You have several test cases where you test the same thing, and it's not necessary. It just takes time at test execution. You have legacy tests that were good at a time, but in fact, you no longer need it because it's a feature that's no longer used, or for whatever reason. But we usually are reluctant to remove tests. We are happy that they exist because we want to do a lot of testing. We can as well run into the maintenance hell for testing. When we have to adapt our huge test suite, and we do not really understand what happens in the test cases. They are not well documented. They are not really structured. It can be very difficult to maintain test cases. And we also have the equivalence of the big ball of mud, which was no architecture in the code or for the code. We can also have test cases that have been created, but not with a structured approach, no test design. We are not systematically testing equivalence partitions, so we just wrote test cases. And this is another form of an equivalent in testing of the big ball of mud. But we have other difficulties in testing. For example, we can have issues with the coverage. We have critical cases. Not all features have the same priority, and we should test more when it's more critical. But maybe that's where we test only a bit, or even not at all. If we don't have a clear understanding of the coverage and of the priorities, we also have technical debt in testing, where I didn't find an equivalent in coding. Technical debt is expensive. And I found a nice source that they did a study in the US, so it's only in the US, and they discovered that, in fact, there is a huge increase in technical debt between 2012 and 2023. They analyzed the top 500 US companies, and they found that really this has that this ended up in $6 trillion, the amount of technical debt, which is really an impressive figure. Well, it depends a little bit on the domain, on the industry, because not all industries are affected the same way. When you look at health and life science, for example, they are only present at 9%. And this is, I think, because they are obliged to have very good test specifications, documented test specifications. They have to get a certification to be able to sell the product. And this is probably why they are keeping the test cases clean. Whereas there's a big problem of technical debt in the banking, investment services, and insurance part. And bit less, but also quite important for communications, media, and services, followed by government, by the way. So those three already are much more than half of the companies. So what are the reasons? Well, I think one reason is that we have more and more software. And maybe the software is still written in a very non-industrial way, so rather made by hand. This can be one reason. The other reason can be that we have to deliver faster and faster, and that the pressure augmented. And this is maybe the cause for technical debt. Here we are just speaking about technical debt and coding. But as we all know, testing is not better off. It's rather the contrary. When coding, when the developers are already under pressure, the pressure on testing is really huge. Technical debt forces companies to waste around 23 to 42% of their development time. So this is the maintenance hell. We really run into problems. So the more we accumulate technical debt, the more we have to spend money just to understand what happens. True for coding, but pretty true for testing too. And we also know that most companies don't tackle their technical debt until the problem has ballooned. So it really comes to 1/3 or half of the time you spend in just understanding what happens, and the maintenance hell becomes palpable and really expensive, and you can see it in dollars or in euros. For the developers, we have strategies, especially in Agile. We have refinement sprints. When you look at test-driven development, then we have 3 phases, and the third one is the refactor phase. So you really deliver clean code. We have this tendency of clean code. So they are already a little bit more advanced. In testing, we do not yet have our strategies, but we have reactions to pressure, and these reactions have effects, and that's my personal list of anti-patterns. So the first one is what I call the paradigm of 100% test automation. Do not misunderstand me. I'm very much in favor of test automation. The only problem is I don't like religious belief in paradigms. And 100% is really a high limit. If you think that you can automate it 100% of your tests, this has several negative effects. The first one is that not all tests are easy to automate. And as we want to reach 100% test automation, there's a tendency to say, well, maybe this test is not as important. So they get lower priorities, those tests that are difficult to automate. The second problem I see is that tests become a topic for technicians. The tests have to be written in a programming language, so you need developers, and developers may not have the best understanding of the business case around the feature that has been implemented. And they focus on the implementation. And even if they did not write the code, they have the same way of looking at the problem, at the feature, and the tests are less independent, and they are more focused on how it is made, and less on what is the feature for. And the third effect is that the test pyramid I would say, melts, because we're not necessarily testing less. Remember, at the test pyramid, to the bottom, you have the unit tests, and they are automated. And to the top, we have end-to-end tests and acceptance tests, and they are quite often manual. When the test pyramid melts, well, we get more and more unit tests and less tests to the top, because they are difficult to automate. But again, we lose this view of the entire system, of the feature, of the reason why the feature exists, and of the question, does the feature, the way it is implemented, really fulfill the needs of the stakeholders who asked for the feature? My second personal favorite anti-pattern is the doctrine of complete coverage. Again, this is a valuable idea, to have complete coverage for, let's say, user stories, acceptance criteria, or requirements. But we have a lot of user stories. We have a lot of acceptance criteria and requirements. And this is difficult to cope with. And what are we doing? We are trying the divide and conquer approach. And this leads to the fact that we have a user story with, let's say, 20 acceptance criteria. So we write our tests to check those 20 acceptance criteria. It's a one-to-n relationship between the feature to be tested and the test cases, or the requirement and the test cases. This is easy to manage, because if the requirement changes, you know that there are n test cases that may also change, or that should be repeated. But again, it's a very isolated view. It's like just doing unit tests, only that we are focusing on user story testing and less on end-to-end testing, or even system testing sometimes suffers. And the other problem I see with the doctrine of complete coverage is that they are the famous non-functional requirements, which are not so easy to identify and to map to a feature. They are always present. And it's difficult to obtain one-to-n, or to have one-to-n test cases for, let's say, usability. And so when you really measure the quality of your tests in coverage, quite often the non-functional requirements are simply excluded. They are not coverage items, and so we may have some tests or not, but at least they are not part of this coverage traceability matrix. And if you neglect something, then it's neglected, and this leads to less importance of usability, security, performance, and whatever non-functional requirements you may have. Then we have what I call the multi-resistant test case. Those are test cases that are impossible to kill. It's like a multi-resistant bacteria. They are also impossible to kill. Tests that become obsolete over time, but nobody dares to remove them. As I said before, we are happy to have some tests because it shows that we are doing work. But I have another example, which is more related to test data. Whereas I have the problem that we have test data, and then let's say we have a function that takes 2 parameters. We have test data for the 2 parameters, and then there's an optional 3rd parameter that's added to the function. And in our test data, we'll probably add test case testing this 3rd data parameter, but all the other tests remain the same. Because the parameter is optional, we can also leave it empty. And we will not touch the old test cases because it's a lot of work and we have to understand it. And so the tests, the quality of the tests regresses over time. And when we come to the point that the parameter becomes mandatory and no longer optional, then we have to find out where they are. We have to fix it. And anyway, even in a more general way, maintenance starts eating up innovation. We are not spending our time in writing good new test cases. We are more spending time in keeping the existing tests up to date. So what I propose is that from time to time, we should throw everything away and start again and write clean test cases. But that's difficult, and you need budget for it. The last one is the phobia of reality. The phobia of reality is that you do not really know what the users are doing and how they work with your product, what they really need. And I called it phobia because it's not only really known, we do not really want to know it. Again, maybe because we have more and more a technical view on the software. And knowing the users, it's difficult. We have already to know them. I mean, personally, to talk to them. And that's not always obvious. And then I also observe a tendency of saying, well, the user was wrong. When the user did something, I feel this sometimes when I'm the user and I say, well, that's not working as I expect, and I'm told that my expectation is wrong. No, it isn't. It's my expectation that should rule the requirements and should rule the feature. So when you hear or you observe in your team that you have the tendency to say, well, that was a user error, investigate because it might be the phobia of reality. The last point is that we quite often ignore the productive environment. I have for example, I'm working for a French company, so they always have their computers and with a French operating system, but mine is in German. So I realized that sometimes the behavior is different because the cookie pop-up, for example, is in German in my case. So my productive environment is different from theirs, but as they need the information because not knowing the user environment, they weren't aware of it. Okay, many problems. But we don't want to talk about problems, we want to talk about solutions. So I have some personal preferences also. This is not a complete list, and not an exhaustive list, but this is what I think how we could start dealing with technical debt. And the first one is exploratory testing. I'm a big fan of exploratory testing. It's not linked to coverage. It's not automated. It's manual, and it's based on experience. And this is, I think, it's not very expensive either in the sense that you do not have to set up a big environment. And it's very effective. Exploratory testing is discovering a lot of bugs and also the discrepancy with reality. It has a nice secondary effect, which is that this experience of the manual testers is evaluated. Because without an experienced tester, you can't do good exploratory testing. And the asset of your testers, the experience of your testers is the best asset you have in your company. Sometimes I feel that this is highly under-evaluated. Second is visual test design or model-based testing. Those who know me know that I'm a big fan of model-based testing, but I'm not going into details of drawing diagrams, etc. Just what I want to say is that this is a way, using visual representations of your test cases is a way of documenting your tests, your test idea, and of communicating on the test idea in a very easy way. But my experience shows that this is investing into the maturity of your test process. And I think that is something we should do to cope with technical debt and to avoid that we accumulate technical debt, I have the opinion that we should, in our organizations, invest in the maturity, have an application lifecycle management tool, write requirements, document them somehow, and if you don't want to write text, then it is sufficient to just draw a picture of how the product is used. That's very good documentation, and it's not so difficult to do. It will be very helpful. We have now the possibility to use generative AI. We have ChatGPT, Mistral, Claude, Gemini, Copilot, and all those other large language models that will help us writing requirements, writing test cases. And this is really a good thing. But they won't solve the problem of the phobia of reality. I'll come to that back later on. The third thing I think is we should do like the same like the developers. We should introduce the idea of refactoring our test cases. And we should also have a concept of end of life for our tests. So one idea would be, for example, if you work in an agile environment, to say that every sprint has its own tests, and that we also do variations of our regression testings. We do not just grow our test suite with the accumulated test cases from the different sprints, but the tests from the past sprint are also reworked. There's this Marie Kondo method. You probably heard about her. She says that everything you never used during a year, you can throw away or give away. Well, I'm not really a fan of that, because in years where there's no snow, I still want to keep my skis to go skiing the year after. But nevertheless, this is worth a try. The same concept also exists for features. Each time you add a new feature to your product, you should think about 3 features to simplify or to remove. And maybe we should apply this approach to our test suites. Each time we add a test, we should also think of removing existing ones. And last but not least, I'm pretty convinced that we should use tools. I already mentioned the ALM. I already mentioned test automation, but there are others. There are, for example, static code analysis tools that help us in our automated testing to identify death code, for example, or copy paste. There are tools that measure code erosion. For testing, for manual testing, it's a bit more difficult, but there is a tool that is available now, which is generative AI. So we can use generative AI to clean up our test suites. And what I recommend is that instead of thinking about how to give our tests to GenAI and how to write a prompt that makes the LLM clean up our tests, try a meta prompt. A meta prompt is a prompt where I ask the LLM to write a prompt. So instead of writing the instructions myself, I tell the LLM what I want to do, what I think what the steps are, the necessary steps are, and I ask the LLM to write the prompt. This is a very nice method for any complex problem, by the way. So I brought an example, which I tested. You are my assistant who helps me to write good structured prompts. So this is the role of the LLM. Here's my problem. I have a number of manual test cases that have grown historically. Each test case consists of a sequence of numbered test steps with an associated expected result. So I explain what the data, how to read the data. These test cases have several problems. They are partially redundant. The same test steps are formulated differently. The test cases are difficult to automate because they are not parameterized, but contain concrete test data in the test steps and expected results. Then I explain so this is the situation. Then I explain where I want to go. I follow a keyword-driven testing strategy and want to standardize the test cases so that they can be easily translated into a keyword script. Caution, even after standardization, all situations and combinations before test data and test data were tested in the original test must still be tested. I have to rework that. I realize. Propose a prompt. So you see the concept of the meta prompt. You explain to the GenAI where you want to go, and then you get a prompt, and you can try this prompt with your test suites, and I think it works. My experience is that it works. I hope it also works for you. But there are other tools. For example, talking about the phobia of reality, we have the tool from smart testing. The team I talked about when in the beginning I said that we discussed the technical depth. And I just want to explain the concept. The concept is that you have your productive environment. And in the productive environment, your users are doing things. They are clicking on buttons, they are filtering lists and so on. And you can get information from this productive environment. Of course, anonymized, because we don't want to know passwords or amounts of things that have been ordered. But this is information you can get from your productive environment. And you have the same information in your testing environment. Because in your testing environment, you run the application. You have manual testers that click on buttons, that filter lists, and so on. And even the test scripts are just clicking on buttons, filtering lists. They do the same. So we get similar information from the test environment. And then we can use the tool and the AI in the tool that creates us insights about the coverage of what happens in reality, what users are really doing. And we will discover that we test features that are merely not used, and that we have very few, if any, tests of what is really important, because all our users, or a large majority of our users, are doing that. This is one example of a tool you can use to cope with the problem of the phobia of reality. And I don't want to go more into detail. You know how to contact me if you want to know more. I would be glad to get in contact with you on LinkedIn. That's my QR code here. If you want to link with me at LinkedIn, and I'm happy to answer your questions. Thanks you. Bye-bye.
Hello, Anne. Hello. Thank you so much for that. A lot of detail and a new concept for me, the phobia of reality, that I'm going to be looking back at the slides and delving into that a little bit more deeply. I'm going to ask the team in the technical team if we've got any questions for you, Anne. You said that the test pyramid melts, but isn't that a good thing? Having more automated unit tests and less manual acceptance tests seems desirable.
Yeah. I have to say that I once worked in a project where we had so many automated tests that we even had problems to execute them, all of them, during the weekend. It's not a desirable aim to have a maximum number of automated tests, because automated tests also mean that you have test logs, you have to analyze them. And even if GenAI will also help us with that in the future, or is already starting to help us with that in the future, it's not, having automated tests is also time consuming. So it's in my opinion, it's of no use to automate just for automation. That's what I wanted to say with this 100% automation paradigm. We should automate things that matter, tests that matter. We also need test design for automated test cases. And that's why I think that it's not a good thing to have a test pyramid that is too large. I thought of an ice cone that melts and that becomes larger and larger. And the other thing I already said is that I really think that those end-to-end tests are important, because they are not only the testers keep them in mind, and the users.
Thank you. We got another question. Can you elaborate more on the meta prompt, please? Isn't it more difficult to write the meta prompt than to write the prompt itself?
No, it is difficult to write a meta prompt because you have to explain what you really want to have. And the real problem is that you do not really know when you start writing the prompt, you do not really know where you want to go. This is, and you realize when you explain it. But as always, if you are not able to explain something, you will not get what you expect. If you're not clear about your expectations either, then it's of no use either. So writing a meta prompt is really a nice exercise, because you become more clear in your mind where you want to go. And finally, it's more, we are used to explain things to persons. It is easier than thinking of really the best way of separating the information in the prompt, etc. It's the LLM that knows best about the format it is that is best for itself. So leave that to the LLM and work on the meta prompt. Really, it's fabulous, the results you obtain with the prompt you get from the meta prompt.
And I think we've got time for one more question. Okay, the tool you presented, is it just an analysis tool or does it generate tests?
Yeah, of course, it also offers the possibility to generate tests. When you realize that your test coverage is not good, your test coverage of the user journeys, so of what is happening in reality, is not good, then you can use the information that has been captured from the productive environment and generate either manual tests or automated tests for Cypress, for example, or Playwright.
Thank you. We're coming to the end of time, Anne, so I'm going to say thank you so much. If people do have some questions, please still pop them in the chat, and then we'll try to get those to Anne so that she can respond. And as she mentioned earlier, please do link in with her, and I know she'll be very pleased to do that. And don't forget that we have our voting, so go to Anne's profile on the A4Q Testing Summit website and cast your vote, please. And stay tuned for the next session. Finally, thank you very much to Anne. It's lovely.